computer are these properties, and that will give us indices, and we will correlate by statistical methods that will give us the properties of chemical trap, actual properties that will correlate with their properties. What is topological invariance? Quantitative derived from the structure of a graph. As actually it will be discussed that n polynomial will be calculated, then we will calculate some quantitative descriptive that will derive from the structure of any graph. Used in QSPR and QSR modeling as discussed earlier. Common degree based indices that are used nowadays, these are Zagreb indices, Radix index, atom bond connectivity index, geometric arithmetic index. What is the role in graph theory? Correlate molecular structure with physical, chemical and biological property. It is not only application in the chemical but also in the biological, where like cancer, cell divide day by day or cell damage day by day, we can also use these relations and these indices. Next, entering our problem statement, a well-studied analysis of structures and chemical positions, networks, molecular structures using different degree-based characteristics. Graph with parameters such as distance, reversibility, reduced reverse degree, connection number, and neighborhood degree. These parameters are also associated with the F polynomial and differential operators and integral operators used to address this issue. The main objective of our work is to analyze the architecture of molecular graph, networks, molecular structures to determine their graph polynomials, differential and integral operators, and estimation of physico-chemical features of chemical structure and graph parameters. So in short, we say that we will use the degree or distance or such kind of other degrees that are defined earlier, or we may define some new such degrees, so that we can use in this n polynomial to analyze, and then operator and differential and integral operator are used for this issue to calculate the individual invariants, and then we will correlate with the graph polynomials so that it will give us physico-chemical features of chemical structures and those graphs. Next, our objectives. We intend to define some new degree-based topological invariants, indices and polynomials. We will define some formulas that will help us in redefining and correlating such properties. To compute some existing and newly defined topological invariants of some graph and graph operations, to analyze the topological properties of some molecular networks and graphs by computing some existing and newly defined topological invariants. So what is our methodology we will use? The main concept is the M polynomial function that we described also earlier in the literature. From this polynomial, we will define some differential operators as discussed earlier, that will be dk with respect to k variable. Differential operator is equal to k partial m over partial k, and dh is equal to h partial m over partial h. Similarly, integral operators are also defined on this. Integral from 0 to k limits 1 by z and dz. IH is equal to integral from 0 to h 1 by z and dz.